All right, so here we go. Quick reminder, you have a test coming up when? Tuesday. It will be over all of Module 19, so we're on 19-5. This is the last section of Mod 19. So you'll be tested on Mod 19, 1, 2, 3, 4, and 5. Those 5 sections. Okay?
That's stuff before spring break, right?
Yes. Yes, that's before spring break. Okay, so let's see. Angle relationships in circles. We've got 2 theorems we're going to talk about here, and then we're going to see some more situations that are kind of similar. So the first situation I'm looking at right here shows 2 chords intersecting inside a circle. One of the chords would be CB. The other one is DA. And when you have 2 chords intersecting, we saw these yesterday a little bit, they make an X, right? They don't necessarily have to intersect at the center. That's not necessarily the center of the circle. It's just an intersection point. But whenever you have 2 lines that cross, you get 4 angles. Do you see that? Angle 1 is listed. You also have an angle here, an angle here, and an angle here. Right? So, the way you can find the measure of an angle is angle 1, and actually this angle would be congruent, correct? Because they're what? Vertical angles. So those 2 would be congruent, and these 2 would also be congruent to each other, correct? So you find one, you found both. Now, the way you find the angle is, it is 1/2 of the 2 arcs that are made from it. So, I have arc AB. Would you say that corresponds with angle 1? Okay. The other arc we're going to say that corresponds with angle 1 is this guy right here, because it's the arc that goes along with the other angle that's the same measure. So to find the measure of these angles, you do 1/2 of this arc plus this arc. That's what this is saying. To find the measure of angle 1, which is this angle right here, you do 1/2 times the measure of arc AB plus the measure of arc CD. Does that make sense? So let's come right down here and look at these 2 examples, because this picture looks very similar to the picture we just looked at. Now they've labeled an angle as angle 1, right? And let's see, I'm going to use my pencil so I can erase if I need to. They're telling me the arc PS is 30 degrees. So I've got that labeled. Yeah? They tell me that arc RQ is 60 degrees. What is the measure of angle 1? Well, from above, the measure of angle 1 is going to be 1/2 of these 2 arcs added together. So 30 plus 60. What is 30 plus 60? 90. So 1/2 of 90 is?
45.
So angle 1 is 45 degrees.
Oh, I like that.
Pretty easy, right?
I like that.
Okay. So number 2, if the measure of angle 1 is 40, so I'm going to erase my measurements now and put some different things here. If angle 1 is 40 degrees and arc RQ is 60 degrees, what is the measure of arc PS?
Oh, now you know.
So I'm going to call that one X, because that's what I'm trying to find. So 40 degrees is equal to 1/2 of 60 plus X. Right? Isn't that what it says? Now, I have a couple options. I could distribute the 1/2 if I wanted to, but I don't really just like distributing fractions. I don't know about you. Or I could get rid of the fraction right off the bat by multiplying both sides by 2. Why 2? Because it's the reciprocal of 1/2. So if I multiply both sides by 2, That gives me 80 equals 60 plus x. Subtract your 60, and 20 equals x. So PS is 20 degrees. Does that make sense? Okay. So turning over to the back side now, you're going to try numbers 1 and 2 on the back side. All right, so this problem right here says determine the measure of the angle by implying the theorem. So we have the measure of angle RPS. So they're asking me for this angle in specific. So what do I know about that angle? I know that to find that angle, I take the two arc measurements, which are 59 and 201. I add them together and do what? Divide it by 2 or multiply by 1/2. So what is 59 plus 201? 260, and 1/2 of 260 is? What is it? 130. So the measure of angle RPS is 130 degrees. Now, always look and see, does that seem reasonable? This is an obtuse measurement, correct? Is that an obtuse angle? Yeah, so that seems reasonable. If I got an obtuse measurement, but I was talking about an acute angle, or vice versa, an acute measurement and I was talking about an obtuse angle, then there might be something telling me that I did it wrong. Okay? All right. Number 2, measure of angle YUV. YUV. So they're asking for this angle right here. So again, it's going to be 1/2 times the two arcs added together. So 68 plus 94. What is 68 plus 94? 162. And 1/2 of 162 is? 81. So 81 degrees is the measure of that angle right there. Any questions about those two? Beautiful. Okay. So let's go back to the other side and look at our second piece of information. Now this drawing looks a little different, doesn't it? This has a ray here that happens to make a chord, but it continues on. And we learned yesterday what that's called. What is it called? A secant. If you have a chord that continues on, it's called a secant. And then this right here is only touching my circle once, and that one's called a tangent. So I have a secant and a tangent here. So if I want to find the measure of x, y, z, so if I want to find this angle right here, it's going to be equal to 1/2 again times the measure of this arc right here that's inside the angle. So there's not two arcs to add together like there were just a minute ago, but it's just 1/2 of this arc right here that is inside the angle. Okay? So let's look at number 3 right here, because we have a picture that's similar, it just is a little bit upside down, right? So they're telling me that the measure of arc LN, that is this arc right here, is 160. What is the measure of angle MLN, or this angle right there? Well, how are they related? The angle is 1/2 of the arc. So if the arc is 160, what's the angle?
80.
80.
Oh.
Easy? Okay. So let's look at the next one. I'm going to erase my numbers because they're giving me new ones. If the measure of angle MLN is 92, what is the measure of arc LN? So what am I doing this time? Going backwards. So I have the smaller number, I have to multiply it by 2 to get the bigger one. What's 92 times 2? 180 what? 4. So I have 184 degrees. Okay? All right, turn your paper over, and I'd like you to try numbers 3 and 4. Okay. So, measure of angle ABE, that's this angle right here. Now, if I ignore all the other junk in the circle, I have a tangent and a secant, right? Or a chord, I should say, because that one doesn't extend. But the same rule applies. They give me the arc as 128, so how am I going to find the angle? Cut it in half. What's half of 128? 60 what? 64 degrees. Okay. Now they want the measure of arc CE, so that would be this arc right here. And if you ignore that part of the circle, you got a similar thing going. You have your chord or your secant side, and you have your tangent side. So if I know that the angle is 68 degrees, how am I going to find the arc? Multiply it by 2, and 68 times 2 is 136 degrees. Make sense? Okay. Over here, LKI, angle LKI, that's this angle right here. Do I know the arc there that ends at I and starts at K? Well, somewhere between K and L. Do I know that arc? It's two things added together, isn't it? So it's 188 plus 50. What's 188 plus 50? What is it? 238. So that's the arc. How would I find the angle? Divided by 2, which gives you 1, what? 19. Okay. All right. Let's erase that, and let's look at what we're looking at now. Measure of arc IJ. Whew. Okay. Now, arc IJ is just this teeny part right here, correct? And I can't find that using my theorem, but I can find arc HJ using my theorem. That if this angle is 46, what is HJ? If the angle is 46, HJ will be 92 degrees. Now they're telling me that this portion is 50. So if I take 50 away from 92, the remainder is going to be IJ. So what's left over after I take that 50 out? Isn't it 42 degrees? And that's how I find HJ. Okay? It was so tiny, it was a little hard to see, yeah. All right, turning your paper back over. So we're good on this top part, right? We got two rules. You're either adding two arcs and dividing by 2, or you're taking an arc and cutting it in half to find the angle. Now, there are 3 more pictures of things that you could get. What do you notice about this circle? You have a point on the outside. You have 2 secants that end up on the outside. Now, yesterday we learned that to find the length of one of the segments, you do the whole thing times the outer part equals the whole thing times the outer part, which is great, but this is going to tell me how to find the angle, not the segments. So, if I have a picture like that, to find the measure of this angle, angle 1, you take 1/2 of the bigger arc minus the smaller arc. So not plus. Plus was if it intersected inside, but intersecting outside, it's 1/2 of the bigger arc minus the smaller arc. Does that make sense? To find an angle, it's 1/2 of the bigger arc minus the smaller arc. This problem is very similar to this one, except what's different? This one, the angle was right on the circle. This one, the angle ends up being outside the circle, doesn't it? So to find the measure of the angle if it's outside the circle, again, 1/2 of the big one minus the small one. 1/2 of the big arc, which would be AC, minus the small one, which would be BC. And this guy, we got 2 tangents. To find the measure of angle 1, any guesses? It's kind of following a pattern here. 1/2 of the big arc minus the small arc. Well, what's the big arc here? The big arc is BDC. The small arc is BC. So to find the measure of that angle, it's 1/2 of the measure of arc BDC, the big one, minus arc BC, which is the small one. So all three of these, the formula is 1/2 of the big one minus the small one. Okay? So let's look at these two problems. If the measure of AB is 60 and the measure of CD is 20, what's the measure of angle E? Well, it's going to be 1/2 of the big arc minus the small arc, which gives me 1/2 of 40, which means that angle E is 20 degrees. The hardest part of these problems is seeing what the picture is asking, seeing what you know and what you're looking for, but the actual calculation isn't bad. All right, if the measure of arc PRQ, so that's the big arc, is 260, and the measure of arc PQ is 100. Now before I go further, do you notice that 100 and 260, if I were to add those, equal 360? That's the entire circle. What is the measure of angle S? Well, same formula, 1/2 of the big one minus the small one. What's 260 minus 100? And 1/2 of 160 is 80 degrees. Okay? All right, turn the paper over and try the remaining 5 problems on the back. So go ahead and try 5 through 10 using all the rules we just learned. It's really that easy, isn't it? Okay, so this one, they tell me this is 116. In order to find x, I have to do 1/2 of the big arc minus the small arc. Well, isn't 116 the small arc? How do I find the big arc? Well, together they make 360, so 360 minus 116. That makes this one 244. So I have to do 1/2 of 244 minus 16. Minus 116, sorry. 244 minus 116 is 128 times 1/2 is 64. So x equals 64 degrees. Any questions on that one? Okay. Let's see, this one's easy. 1/2 of, they give me both arcs. Big one minus small one. So 173 minus 79 is 94 times 1/2 is 47 degrees. I like these. These are easy, aren't they? All right, 1/2 of the big one minus the small one. 113 minus 23 is 90. Cut in half is 45 degrees. And finally, let's see. This one's a little differently. Look at the way it's labeled. What's 12 degrees? 12 degrees is the angle, and x is the small arc. So 12 is equal to 1/2 of 148 minus x. Be careful how it's written. So again, I want to get rid of the 1/2 first, so I'm going to multiply everything by the reciprocal of 1/2, which is 2. So 24 equals 148. That's not 148, is it? The big arc isn't 148. This arc is 148, but that's the big arc I'm looking for, so I got to step back for a minute. Thankfully, they tell me that this is a diameter, which tells me that this whole thing is 180, correct? So if this part is 148, oh, this one's a little more involved than I thought it was going to be. Okay, let me step back for a minute. The diameter is made up of x plus 148 plus the big angle, correct? Or the big arc. That's going to give me the full 180. Right? Because it has to include x and 148 and that guy. So how could I represent this guy? Well, I know it's going to be 180 minus 148 and also minus x. So what is 180 minus 148? Isn't it 32? So this arc is represented by 32 minus x. Does that make sense how I got that? That one's a little messy. So, let me step back now to finding this. So, let's see. Let me get a sticky note so I have a little bit more room to write. So, 12 is equal to, and you can't see on this sticky note very well, use a darker pen. 12 is equal to 1/2, right, of the big one, which is 32 minus x, minus the small one, which is minus another x. Can I still multiply by 2 first? Yeah. So if I multiply everything by 2, I get 24 is equal to 32, and let's go ahead and combine those like terms, minus 2x. Yeah? So I'm going to subtract 32. 24 minus 32 is negative 8 is equal to negative 2x. Divide by negative 2. Thank goodness I'm dividing by a negative because I needed to end up positive somehow. And negative 8 divided by negative 2 is 4. So for number 8, I get x equals 4 degrees. So let's see. All right. So on this last one, or the last two, I should say, we have the measure of yz. That would be this guy right here. Yeah? So I'm going to call that x because that's what I'm looking for. And what would that make this arc? Wouldn't that be 360 minus x? Because whatever's left from 360 gives me that guy. So 60 degrees is equal to 1/2 of the big arc, which is that, minus the small arc. So can I multiply by 2? Yes. So I get 120 equals 360, because that'll cancel out, minus 2x. Move the 360. Negative 2x equals negative what? 120 minus 360, negative 240. Divide by negative 2, and what does x equal? Positive 120, so the measure of arc YZ is 120 degrees. Now, if they asked you what the measure of YDZ, of arc YDZ was, if they asked you that, what would that answer be? 360 minus 120, which would be what? 240, if they asked you that. All right, last one, the measure of DE. I'm going to call that x, which makes this arc 360 minus x. So 100 degrees is equal to 1/2 of the big arc minus the small arc. I can multiply by 2. So I get 200 equals 360 minus 2x. Move your 360. That gives me negative 160 equals negative 2x. Divide by negative 2. And what does x end up being? 80 degrees. And again, if I asked for DPE, measure of arc DPE, what would that be? 360 minus 80, which would be 280. Okay. All right, your homework is out of the textbook. I have posted it in the locker, the 19.5 student edition. And I believe the title of it tells you what problems you're doing for homework. So make sure to check that.